Hi, my name is Justin Cox. I am a fellow in the 2024 cohort of the KaggleX Fellowship, and I will be presenting my final project today. Thank you for the opportunity to participate in this fellowship and for all the resources Kaggle has provided to help us learn and complete this project. And I'd also like to thank my advisor, Anu Deepspree Buffini, for all of his guidance during this project. I'm a data science professional with a master's in applied data science from the University of Chicago that I attained in 2021. I currently work as a senior analytics engineer at an edtech company called Otis, and I hope to eventually move to a machine learning engineer role as my career progresses. For my project, I trained Gemma 2B to be an astronomy question and answer chatbot. It can answer questions about a range of science. It can answer a range of science questions, but I specifically trained it on astronomy questions because I am a space nerd. Um, I use LoRa fine-tuning and hyperparameter optimizations to fine-tune Gemma to answer these questions. And I learned that how to fine-tune a pre-trained LLM. Fine-tuned other pre-trained models before, but never an LLM. So this was an experience for me. Um, I learned how computationally expensive fine-tuning pre-trained LLMs can be. My original project idea was to use OpenStack's textbooks to be a source of questions that can then be trained, that Gemma can then be trained on the questions from those textbooks, essentially turning Gemma into a study buddy bot for any OpenStax textbook that you fed it. But I learned that generating the amount of questions I needed to train Gemma was computationally expensive and too computationally expensive and monetarily expensive for the scope of this project. So I pared down to just training on uh, a pre-compiled science question and answer data set. And this is that data set. I use the SciQ data set, which contains about 13,000 science exam questions about a range of science topics. The answers are in a multiple choice format, but they do include a supporting evidence additional paragraph for the correct answer, and that's the uh, target that I used for training my model. And this is what that data set looks like if you want to uh, use it to train Gemma yourself. So now I'll give an example of training my model. So first I install the required packages. I didn't end up using FICE CPU or blockchain community, but the rest of these were used in uh, training. And then I imported the needed packages and gave access to my Kaggle environment so that I could use the Gemma model. And then I downloaded the SciQ dataset from Hugging Face and processed it to take the question from each document as the input and the support as the target, and then returning a string for each um, in this fashion. So then I imported Gemma 2B and looked at the summary of the base model and tried to immediately ask it some science questions like what is the nature of science, which gave this kind of hallucinatory answer where it started asking a bunch of other questions and answering it itself. And I asked it for the properties of the moon, which it did a pretty good job at, as you can see here. Um, So we were starting to get place that gave me hope that once I fine-tune it, it could give an even better answer. So then I used a rank of 128, which cut down the training parameters to 93 million from the 2.7 billion that it originally had. And then I hyperparameter tuned on the sequence length, which affects uh, how many tokens the model can take as input and can return as an answer, and also the learning rate and the beta 1 and beta 2 parameters, which all affect like the speed at which the learning rate is adjusted and the initial momentum from each learning batch. And I use an epoch size of 2 and a batch size of 3. Um, so now when I ask Gemma 2B these questions, I get the following answers. Some of these answers are good. Some of them do get a little hallucinatory, but for the most part, I was happy with the results. Like how far is the Earth from the sun? The Earth is about 93 million miles from the sun. What is dark energy? Dark energy is a mysterious form of energy that is everywhere in the universe. It is thought to be responsible for the expansion of the universe. What happens at the event horizon of a black hole? The event horizon of a black hole is a boundary of the region from which nothing can escape. The event horizon is boundary of the region where gravitational force of the black hole is strong enough to prevent light from escaping. And it is a boundary of the region where the black hole's mass is concentrated. The universe began with the Big Bang. So I asked it several science questions, and it gave really satisfactory answers. So being happy with that, I saved this model and made it available in my Kaggle profile so that you all can use it if you would like. So that is my presentation and project. Once again, I'd like to thank Kaggle for this opportunity. I'm really excited to have been able to participate in this and thank you all for your support. And I can't wait to take what I've learned here and progress my data science skills and career further. Thank you.